Good morning, students. Today is going to be the 33rd session in the e-content series and under the topic of kinetic theory of gases. Today we are going to study regarding the Vanderwaals equation of state for real gases and Boyles temperature. So in today's class we are going to study Vanderwaals equation of state for real gases and Boyles temperature. Vanderwaals suggested the following correction in the ideal gas equation. That is, the gas molecules possess finite volume and hence should not be neglected. So Vanderwaals had stated that the gas molecules possess a finite volume and cannot be neglected. It is especially true at high pressure and at low temperature. They have to be taken into account. So gas molecules possess finite volume and hence should not be neglected. It is especially true at high pressure and low temperature and should be accounted for. In case of real gases, both the forces of attraction as well as repulsion operate between the gas molecules. So taking into account these two corrections, Vanderwaals had made a correction for the ideal gas equation. So the following corrections were applied by Vanderwaals to the ideal gas equation. They are the pressure correction and the volume correction. They were the pressure correction and the volume correction. Coming to the pressure correction. The pressure of a real gas is less the expected pressure due to attractive forces between the molecules. The pressure of the real gas is less than the expected pressure due to attractions between molecules. These attractions slow down the motion of gas molecules and result in reduction of frequency of collisions over the walls and reduction in the force with which the molecules strike the walls. So as we are going to expect a lower pressure, that has to be added in. So the ideal pressure will be the real pressure plus the pressure correction or the reduction in pressure. So after the pressure correction, the reduction pressure is proportional to the square of molar concentration. It is going to be the square of molar concentration. So P will be proportional to N by V into N by V. So that comes to be P plus the pressure correction will be A N square by V square into V will be equal to nRT. So this is once we have corrected the pressure in the ideal gas equation and the pressure correction is A N square by V square into V is equal to nRT. Coming to the volume correction. The volume available for gas molecules is less than the volume of the container. The volume available for gas molecules is less than the volume of the container. The available volume is obtained by subtracting the excluded volume N molecules from NB of the volume of the container. So available volume will be, this is going to be the excluded volume, that is V minus NB, where B is a constant characteristic of the gas. Now the ideal gas equation after volume correction is going to be P into V minus NB is equal to nRT. And the final Vanderwaals equation is going to be P plus A N square by V square. This is the pressure correction into V minus NB. This is the volume correction. And ultimately the Vanderwaals equation will be P plus A N square by V square into V minus NB is equal to nRT. The Vanderwaals equation. Coming to what is a Boyles temperature. Boyles temperature is the temperature at which real gas behaves ideally over large pressure range. Boyles temperature is that temperature at which a real gas behaves ideally over a large pressure range. So this is going to be, if it is going to be an ideal gas, then this is going to be the ideal gas equation. But if there is going to be, if the pressure is going to be increased, they are going to get deviated. So that temperature at which the real gas behaves ideally over a large pressure range, that will be called as Boyles temperature. TB is equal to This is the Boyles temperature will be given by A by RB, where A and B are the van der Waals constant. Boyles temperature for a gas is always higher than the critical temperature. Boyles temperature is always higher than the critical temperature. Okay, thank you.